Hello everyone, welcome back to Native Engineering. Today we are doing suddenly applied load, which is the third way in which a force can be applied to an object. So an example of a suddenly applied, we are having a road, and there is an object. The object is directly in contact, it's in direct contact with this collar right here, but this object is independently balanced. What do I mean by that? Let's say you have two guys and they are balancing this object. The object is not balanced by this collar, but is in direct contact with this collar. So this it's independently balanced by these two guys. So all of a sudden, these guys, hence suddenly applied load, they let go of this object, and now the object is being balanced by the collar which is in contact with. So that it's an example of a suddenly applied load. It's what suddenly applied load is. So remember we said when we were dealing with shock load that the potential energy at the top will be equals to the strain energy at the bottom. We know potential energy, it's given by mg h, where our mg will be equals to W, which is the weight. As the force is released by those two guys, it will cause a strain on this rod. Therefore, it will come, let's say it comes here, the rod, together with the object. Then this will be our change in length, which will be this height. Therefore, here we are going to have what? Weight times xt as our potential energy. And we know this is equals to what? Half force total change in length. This and this will cancel out. Then we are going to have force being equals to 2 times the weight. Then from here we conclude to say that the force that will be applied to the collar as these two guys release this object will be twice the weight of the object, the actual weight of the object, as we are seeing from this derivation. Our formula for strain will then be, we say F is equals to 2 times W. Strain, we know it's calculated by half F X T, where this is equals to this. Therefore, we're going to say 1.2, 1 divided by 2 rather, it's equals to, here we put 2W xt. This will be our formula. We said what? Strain, it's equals to potential energy, and our potential energy is W xt. Therefore, we are going to say, we know this, it's equals to F L divided by AE, where we are going to substitute AE. And the value of F is equals to what? W 2W L divided by A E. And then we are going to end up with the equation that says U it's equals to W, it's 2W squared L divided by A E. So there is nothing new here and there is nothing to cram. You are going to just use what you have been using all along. This formula we have been using ever since we started with this topic, so there's nothing new. Here, this formula, we derived it with you. So this is everything that you are going to need to start with suddenly applied load. I will see you on the next lesson.